Okay, welcome everyone. Today we are going to be working on rational functions. Now a rational function is like what you see here, where it is a ratio of two unknown values. So the steps to solving this: first, you're going to factor and reduce if possible. We just want to make both the numerator and the denominator as simple as possible before we do anything else. Number two, we're going to find our asymptotes. Our asymptotes are the values that y and x both cannot be. We'll get more into that in just a little bit. Three, you're going to find your intercepts. Your x and y intercepts. That will tell you what direction the graphs are going to go. And once you have all of that set, you are then going to graph. Okay, so we have this sample problem here. Just going to work on it right here. Okay, first we're going to factor it. So the top, yes, it does factor. It factors to x plus 3, x minus 3. And the bottom, does that factor? Yes, it does. Factors to x minus 2, x minus 3. Oh, and look at that. We already saved ourselves a whole bunch of work. We can cancel both of these. Just have to keep in mind that even though we canceled both of these, x still cannot equal exactly 3. So we're going to make a note that there is a hole at x equals 3. But as far as this is concerned, we can just assume both of these are 1. Treat them both like they're 1. Okay, so that is our reduced fraction. Now we're just going to find our asymptotes. Our asymptotes are the values that x and y both cannot be. So to find what x can't be, we're just going to eliminate anything that can make our denominator 0, because you can't divide by 0. That's canceled out. We don't have to worry about that. But x cannot equal 2, because otherwise we'd be dividing by 0. And as far as our horizontal asymptotes, that depends on the degree that they are. In this case, the degrees are equal. So our horizontal asymptote is going to be a ratio of our leading coefficients. In this case, just 1 and 1. So x does not equal 2, and y does not equal 1. So let's start our graph. We're not drawing anything, any type of line. We're just going to put a dotted line where our asymptotes are. So x cannot equal 2. And make sure we label that. And y cannot equal 1. And make sure that we label that. Okay, step 2 is done. Now we're going to find our intercepts. And how do we find those? Very simple. To find our y-intercept, we're just going to make x 0. And so we get 3 over negative 2 times 1 times 1. So our y-intercept is 0, negative 3 halves. Then we're going to find our x-intercept. Once again, just to make our y 0, all we got to do is make our numerator equal to 0. So we only have one choice there. Our x is going to be equal to negative 3. So we have our 2 points, 0, negative 3 halves, and negative 3, 0. No intercepts over here, so we are ready to graph. Okay, so we're going to start at this asymptote. Now this doesn't have to be perfect. We're just sketching, getting a general idea. It's going to cross through our y-intercept, Then we're going to go through our x-intercept. We're going to approach y equals 1, but not quite touch it. That's the first part of our graph. But what about when x is more than 2? Well, here we look at the degree of our asymptotes. So this x plus 3 that's here, we can picture that as being x plus 3 to the first power. And we can picture this as being x minus 2 to the first power. So because of that, if the asymptote has an odd degree, that means that when you come from the other side of the asymptote, you're going to come over from the opposite side. If they were even, you would start on the same side. It would kind of look like a volcano. But here we're going to work from this asymptote. Not going to draw it yet. I'll tell you why in a second. And we're going to approach, once again, our degree's odd. So we're going to approach from up here. Now, why am I not drawing this yet? Because there's one more thing that we have to account for. We have our hole at x equals 3. So to find where the hole is, we're going to plug 3 not into this, but into the original equation. And we're going to get oh, no, sorry, not into this. We're going to plug x into our canceled equation, not our original one, our canceled equation. And so we get 3 plus 3 over 3 minus 2. And we get 6 over 1. So our hole is at 3, 6. So we mark our x equals 3, and we put a hole right around 3, 6, which is right around here. However, the coordinate spot is not 3, 6, because if we put this into the original equation, we end up dividing by 0, so it's actually undefined. So our plot point here is 3, 6, but just remember that that's not actually a point and it's actually undefined. And we're just going to trace through and trace through. And there we have it. We have a graph of this rational function. And these steps, they work for any rational function at all. Just remember to lay out as much as you possibly can before you start graphing. It's going to make solving the final solution a whole lot easier. Right, thank you very much for watching. Good luck on your next test.